Here for Enigma Q, we have three basic engines. The engine for remote sensing, image processing, and analysis. And the second engine is the geophysical engine. And the third engine is the 3D geological modeling engine. At the top, for the top menus, you have both of the remote sensing, image processing, and analysis integrated with geophysical engine at the top menus. At the left tree, we have the 3D geological modeling and integrated also with a geophysical engine at the left tree. So let us start by the first pipeline, which is responsible for the top menus for both of the remote sensing, image processing and analysis, and the integration with geophysics. First step, we go to Copernicus or United States Geological Survey and look for your area of interest, type your country. For example, if you type Egypt, okay. Now, for example, if you type on your search a place uh, for your area of interest, for example, I would choose a place on the Eastern Desert. Okay, now you have to select your area of interest. Just draw a polygon here. This is the area of interest. Then the search, open the search. Just for the search, select the type of satellite. We choose Sentinel 2 and then select the date. Let me select from year 2024 to 2025. And for example, for February, yeah. Then click on the search. Now we have these satellite images corresponding to our search, and the white block represent our area of interest with respect to the whole satellite image here. This is the area of interest with respect to the satellite image. Just look for some image that contains completely your area of interest, for example, this one here, and just click on download to download your area of interest. Now, after downloading, you will get this compressed file. You have to decompress the folder. You have this compressed file. Just decompress it or unzip it to open your data downloaded from Copernicus website. Just open the GNU and open the L1, open the image data. You will see here the different bands in the format of GB2. We have here band 1, band 2, band 3, band 4, band 5, 6, 7, 8, 8A, 9, 10, and band 11 and band 12. And this is a false composite color here, which is total or total composite color, false color, red, green, blue here. Now go to our software, Enigma Q, and from import, just click on import, okay, and go to your downloaded file. In GNU image data, and we start by loading band 2 because we don't use band 1 here in our manual exploration. We start by making a stacking of band 2, 3, 4, 5, 6, 7, 8, 8A, and also we skip band 9 and we skip band 10, and we stack it with band 11 and band 12. So start by importing band 2 here. Now this is band 2 that we have uploaded to our Enigma Q. Just go to the band menu and click on stack bands from another image here. Then select band 3, band 4. Just type on control on the keyboard and select band 3, 4, 5, 6, 7, 8, 8A, and skip 9 and 10 and select 11 and band 12 and click open. This will stack band 2 with the other bands, and just wait until it finish stacking the bands. You have to wait until the image, the successful message appear on the screen. Now this is our stacking success message. They say that files have been stacked successfully. Just click OK. And now we start on the next step. On the next step, we go to the pre-processing and DEM menu, and then assign the spectral bands manually. Okay, now we have to assign the band for blue band, the green band, red band, and the near infrared, and the SWI R1 and R2 and R3, and the thermal band here. So for blue band, it will be corresponding to the first band that we have already imported, which is band 2. Here it will be corresponding to band 1 because it is the first one that we have chosen. For green, we select band 2. For red, we select band 3. For near infrared, here we select band 7. And for SWRR1, we select band 10. And here for Sentinel, it doesn't have SWI3 or TIR. So we select band 11 for both of them. And then save and apply the quantum mapping. Just here, band mapping have been applied. So click OK. Now go to the next step. We go to the settings for the quantum circuits. We adjust the gold threshold. For example, we keep it as 0.35. We adjust the diamond threshold. Since the area doesn't have indicators for diamond, so we raise the threshold to about, for example, 0.80. And we adjust the copper threshold also. I will raise to 0.65, for example. And for water, we adjust it to 0.65. And for graphite also, we could use the same threshold. It depends about the target you are looking for here. Now go to File and Run Pipeline with the selected area of interest. But before running the pipeline, just select your output folder on which you will save your analysis. So I will make a new folder here on D. Okay, and save it as gold mine, for example. Gold mine. Okay, just select this folder to as output folder for our analysis here. And just click on select folder. Now go to File and Run Pipeline with area of interest. Just crop your area of interest here and just click on Run Pipeline on selected area. You could adjust your resolution. 100% resolution will take a longer time, but it will make an accurate analysis. But other resolution categories as 75% or 50% is the fastest one, but less accurate, and the ultra fast is 25, but it is not accurate at all. So I will keep it as 100%. It will take longer time depending on the area you have cropped, and just click on Run Pipeline on selected area and click here on Run Pipeline. Now the first step, it will show the information about the satellite Sentinel-2. Just close and go to your file that you have, go to your folder that you have specified as output folder. It is gold mine, this folder. Now it starts the analysis. You will see the corrected visual, the multi-hero shade, the proxy digital elevation model, the geometric corrected, and the MNF transformation hydrological network, and also topographic normalized image. Just wait until it finish. You will see at the corner, at the bottom left corner, the steps that are going in the background. Now you have the lineament map and also the lineament density. And the geo AI slope and the classical anomaly and the bandmass minerals and the structure and the sub-pixel mineral mapping and the BBI map. Just wait until it finish. Now this is the unsupervised classification, and you have also the supervised classification. Just wait until it finish running all the pipeline. As you see at the bottom left corner, this is step 16, generating the overlays and integrated maps. Now, step 23 is the end of the pipeline. Now the pipeline has been completed successfully. Just click OK, and you could see and review the results of this analysis pipeline. First, this is the geometric corrected. And second, you could see the topographic normalization, the multi-hill sheet, the proxy digital elevation model here. And also you could see the hydrogeological networking here, the MNF, the BBI, and the unmixing. You could see for bands, you could see the NDVI indicator for vegetation, and also the clay ratio and the iron ratio here. Uh, you go to display, this is the corrected, the structure, the NDVI, and the fingerprints. You could see now the fingerprints for gold. Now, according to the color scale, the dark brown areas are representing here gold. This is the dark brown areas. This is a signature for gold. Going to the fingerprint for diamond. Now we have some small area with a violet, which are geological indicators and spectral indicators for the geological environments for diamond. Going to fingerprint for copper, also you have some dark brown areas according to the color scale are representing the spectral fingerprints for copper geological environments. This is groundwater. The blue, we are looking for blue here representing groundwater. And going to fingerprint of graphite. Here we are looking for black. The black will represent the fingerprints or spectral fingerprints for the geological environments of graphite. For uranium here, and for lithium, here we are basically looking for structure or structure tectonic settings that favors the presence of lithium. Going to fingerprints of iron, red, which is represented here as dark red. Going to fingerprints of bauxite. Unfortunately, we don't have any indicators for the geological environment of bauxite. Going to fingerprints of silica. Here, these areas, according to the color scale, representing the silica. Going to fingerprints of, you have also a complete chain of the gemstones that could be identified from spectral signatures of their corresponding geological environments. For example, the sapphire in blue, the also gemstones, we have emerald in green, the fingerprint for tourmaline, the fingerprints for topaz in dark brown, the fingerprints for garnet in dark red, the fingerprints for amethyst, the fingerprints for quartz in black, fingerprints for beryl in dark blue, the fingerprints for zircon, the fingerprints for peridot in green, the fingerprints for jade also in green, the fingerprints for spinel in pilot, the fingerprints for tanzanite here, and the fingerprints of opal. This will be in white according to the color scale. Take care that here we are looking for the geological environments that favors the presence of certain mineralizations. So all the spectral indicators here are related to the geological environments that will be suitable for the presence of these specific mineralization. Also, you could show the overlay for gold, overlay for diamond. Here we don't have indicators for diamond, overlay for copper, overlay for groundwater, overlay for graphite, overlay for uranium, and so on. And also you could see the overlay for different gemstones, for example, topaz or any other gemstones. Now, important is the integration because it takes the integration between the spectral indicators and also the structural analysis. This is a result of integration between the spectral signatures that are related to the geological environments for these specific types of mineralization and also the structure indicators for these types of mineralization. Let us see the integrated for gold. Here you have the dark brown according to the color scale. This is the favorable sites for gold mineralization. Going to integrated for diamond. Here we have only very small areas that is restricted to some faults in this area. Going to integrated for cover. Also, we have very small areas and integrated for groundwater. This is related to the lineaments and also integrated with lineaments. Going to integrated for graphite, only very small areas. And going to integrated for uranium, again, very small areas. Integrated for lithium, here related to the fractures and lineaments. Integrated for iron and integrated for bauxite. Here also we don't have any indicators or spectral indicators for bauxite, but there is some structural indicators only for bauxite. We should depend on both of them, on the spectral combined with the structure. Here we have only a structure, not spectral indicators for bauxite. Going to integrated for silica. Here we have some wide areas for silica related to hydrothermal solutions. And also you could see integrated for topaz or any of the gemstone. This is, sorry, the contours, the integrated for topaz, for example. This is integrated for topaz and integrated for peridotite, for example, and so on. Also, we have the fingerprints for hydrothermal reservoirs, for geothermal reservoirs. This is the fingerprint for geothermal, and the also the fingerprint for the thermal anomaly. Here we look for the white and yellow areas according to the color scale. Yellow and white areas here. Also, you could see the overlay of geothermal and thermal anomaly, and you could see the integrated poles of geothermal and thermal anomaly. Here's for thermal anomaly, for example. You should look for white according to the scale. For white, here is the large probability for hydrothermal reservoirs in this location. You have also the contours for gold. This is a contour, will produce a contour map for the probability of gold, the probability of diamond, the probability of copper, the probability of groundwater here, the probability for graphite, and so on, the contours for and also gemstones and geothermal. For example, thermal anomaly here. Now going to important one is the combined mineral wealth map. If you click on this option, it will create the combined wealth map. As you see here, this area, which is the gold mine in the Eastern Desert, here you have the yellow according to the color code representing the gold, the presence of gold, and the blue representing water or indicators for water, and you have white some white areas for small areas that could be for indicators for graphite. You could also adjust the geological settings. From settings, you have geological environments. For example, if you exclude the copper, because the area doesn't have copper here, and exclude uranium, and exclude the lithium environments, and also exclude the graphite environments. Just I will keep iron, but exclude bauxite environments and diamond environments. Also, you could select the environment of gold, whether it is epithermal or porphyry or placer deposits. You should, for example, exclude the placer deposits of alluvial gold and keep the structure and the porphyry and epithermal. And just click on recalculate the fingerprints. The engine will recalculate the fingerprints, and now after recalculating, you go to the combined wealth map. Here you have the difference between this map and the previous map. Here you have some white areas filled with yellow corresponding to gold here. This is for the display of this combined wealth map. Also, you could show the lineaments here. This is the lineament map, and you could show the lineament density and the 3D depth map and the 3D terrain viewer. As you see, this is a 3D terrain viewer. This is, you could rotate it and you have the elevation scale. This is the 3D terrain viewer. Also, you have the possibility if you imported some boreholes, you could also see the 3D geological intelligence model. Since we didn't import a borehole, so it shows the same like the terrain model. Now going to the drill. Drill menu is important. This is a suggested drill locations for each mineralization. For example, for gold, for diamond, for copper, for groundwater, for uranium, and so on. Also for all gemstones and also for thermal anomaly. But the most important is the exploration ranking. Here we make exploration ranking map for gold. The red area means high priority for presence of gold. The yellow means medium priority. The green will mean low or none, low priority or none. And the black is non-priority for gold. Also, you could prepare a ranking drill for any this is the ranking for diamond. As you see here, we only have very fine or very small areas that will be negligible because only these very small areas are related to the geological environment for diamond. Also, you could prepare ranking for copper. Again, also we have only small area, except at the northeastern corner, you have some area that could suggest for copper. Also, you could make a ranking for groundwater. Here, this is the possible areas which is filled with red that could be suitable for the fractures and the presence of fractures that could be suitable for presence of groundwater. Going to ranking for example for graphite. Again, you have a small areas here for graphite. Ranking for also you have these for gemstones. For example, for garnet. This is for garnet. You have a negligible narrow zones for garnet, for example, and so on for all the other gemstones. Also, you have a ranking for geothermal and for thermal anomaly. Here you have only this part, which is filled with red, for the possibility of presence of geothermal reservoirs in this location. Now, for the other, you have the unsupervised classification. This is the unsupervised classification and the supervised classification. You have the NDVI for vegetation, the slope, and the classical anomaly. Here you have the quantum classical perspectivity. Also, you have an option to select your own spectral fingerprint by from signature. Just click on exact view signature and click OK. It will open your satellite stacked satellite image and just select the spectral for ascertain new mineral. Okay, and just press enter. It will show to you the exact spectral signature and the bands here. Click OK. And just if you would like to save this signature for running the pipeline based on this signature for a certain new mineral, just click yes and make any name for this mineral, for example, new, and click OK. It will add it automatically to the database for this project, and just you will have select active signature from here. You will see our new signatures that we have selected, which is new. You could select it as active signature to run the pipeline based on this signature. For integration with geophysics, you have options to import your real data from here. You could import the grid, gravity, magnetic grids, and also resistivity sections, conductivity sections, or radioactivity grids, and so on. But you must take care that this geophysical data have the same GIS for the satellite image, the satellite image you have chosen. Also, you have option from geophysics to generate a synthetic. If you don't have a real data or field data for geophysics, you could import your real data from here and select your magnetic and gravity grids, and also select the conductivity and resistivity cross sections, and make integration with the analysis results for the mineralization. But if you don't have real data, you could select synthetic geophysical data and to generate synthetic data according to the satellites. After that, it have been generated, and you could review this synthetic data. For example, to view, it will make a synthetic magnetic and gravity, resistivity, conductivity, and the potassium, sodium, uranium. For example, to view the magnetic, this is a magnetic synthetic magnetic grid that have been created, or to show any other type of the synthetic geophysical data, that, for example, thorium. This is thorium grid, and so on. And then you have to integrate with a satellite. Just select the mineral to integrate, for example, integrating geophysical data with the results for gold. Just use the raw synthetic data. This is after integration between the geophysical data and the results of the spectral analysis of the image, the image that we have imported. You could make integration for any mineral, and also for all stones and for hydrothermal. For example, if you would like to see the geothermal, just select, for example, thermal anomaly and use synthetic data. This is the result of integration between the spectral analysis for geothermal reservoirs and the synthetic geophysical data. More important is these filters. These are filters, geophysical filters for regional residual separation, polynomial trend, upward continuation and downward continuation, the derivative edge detection, magnetic specific, for example, reduction to single pole, micro leveling, disturbing, some filters for frequency, low pass, frequency filter, and high pass. And you have the Euler deconvolution from depth structure, and SPI, the source parameter imaging, Euler deconvolution, and warming. You have some processing for radiometric to generate the uranium to potassium ratio, thorium to potassium ratio, uranium to thorium ratio, or view potassium maps, thorium, uranium, or total gamma ray count. If you import Excel files, you have this option to make database reading, and also to make some corrections for these grids that you have created from Excel files. Also, you could make some filters or apply some filters from here. You have also the option to reset to the raw data that before processing. And this is the contour maps for the different geophysical data that we have imported. This is for the geophysical menu. But all of these filters, regional processing, derivative, edge detection, magnetic specific frequency domain, and the depth structure, and also radiometric filters, should be applicable for real data. If you import data from outside, not if you make a synthetic data, just if you import data. For example, I will use here some samples. This is synthetic, this is outer external data for synthetic conductivity and synthetic resistivity, and magnetic grid and gravity grid, and just click OK. And just you have to verify whether the image for conductivity is a vertical section, is integrated as a cross section or horizontal map. Just click no. And also for you will see the same message for this is for synthetic resistance. And so you could apply now the filters. For example, applying residual filters for magnetic. Just select, you have option magnetic or gravity. Just select magnetic. This is the residual anomaly. Just you go to geophysics. Also, you could make the reduction to single pole for magnetic, and just select magnetic, and select enter the date of survey. Also go to the IGRF model on the IGRF website to collect the data about the magnetic intensity, magnetic inclination, magnetic declination, and enter these values here and click OK. It will apply a reduction to a single pole. Also, you could apply some derivatives, second vertical derivatives. For example, for gravity, this is the result of applying a second vertical derivative to gravity. You could apply, for example, tilt derivative for magnetic, and just you have to select the smoothing or the sigma factor and click OK. It will apply the tilt derivative for magnetic, and so on. You have the different geophysical filters for regional processing and upward continuation and downward continuation, and the derivatives, first vertical and second vertical, and the total horizontal, the edge detection, the analytical signal, and tilt derivative, and total horizontal, and the theta map, The magnetic, you have the reduction to pole and the correction for the micro leveling correction and stripping, the low pass filters and high pass filters, the depth structure for source parameter imaging or Euler deconvolution or Bohm. Also, you have these options for generating contour maps. This is the raw magnetic contour, for example. Just this is the magnetic contour map, and also you could see the contours for gravity. Okay, just you could reset to raw data here. Yes, and just go to undo and undo. Uh, just release the check in front of all filters that have been applied to revert. And so this is after undo. So you could see now the contour for raw magnetic contour. Okay. And also the contours for raw gravity. Okay. We have done undo to remove all the filters that we have applied, all the geophysical filters that have been applied here. This is the top menu pipeline involving the image processing analysis and also integration with geophysical processing and analysis. Also, you could see you could make modeling. We have an option for magnetic inversion. Just select the depths, for example, 300 meter, and click OK. And you could see the modeling from modeling display, the 3D geophysical viewer for the magnetic model. Now this is the showing the 3D view of the created magnetic model. Also, you could make the same for gravity. You could model gravity or make gravity inversion and select the depth, for example, 300, and click OK. It will apply gravity 2D inversion for gravity data, and just click OK. And going to model display, you could see either the 2D cross section for gravity or the 3D of gravity model. This is the 3D of the gravity model. The white area, the red area represent the high gravity values or corresponding to high density, and the blue representing or corresponding to low density. Also, you could make modeling for resistivity and just select the depths. This will make 2D inversion for resistivity, and also you could see the 3D for resistivity. This is the 3D of resistivity, and you could see the color scale yellow representing a high resistivity values. Also, you could make it for conductivity here. So this is for this pipeline for both of image processing and analysis integrated with geophysical. After you finish your project, just to be ready for other new project, you have to remove the cache memory from here, from push memory cache here. But before doing this, we could see also some pre-processing analysis like geometric correction for our stacked image. This have to be done before the pipeline itself. Atmospheric correction, just click yes. It will do the atmospheric correction, the terrain illumination, the contrast enhancement. Also, you have adaptive histogram. You have some noise reduction filters, bilateral filter, or Gaussian adaptive or non-local means. Also, you have some edge enhancement. All of these are pre-processing before running the pipeline itself. Now, after finishing, you have to push memory cache from here. Just to remove your memory cache to avoid some overlap between the results of the analysis of the previous project with this next project. Just confirm and it will remove all of your cache memory. Now going to the left tree responsible for or related to the 3D geological modeling and resource classification and also integration with geophysics. Here you have to upload at least the caller and survey and the lithology data files for your borehole. For example, I will select caller from here, import caller. Just go to your data folder. For example, we have a sample here on geological modeling. This is a main project. We have a caller Excel file. Let's open. Now caller have been imported successfully, and just go to survey, import your survey Excel file from here. Okay, now the survey have been imported, and this is the lithology import lithology. Let's select the lithology file. Now lithology have been imported. Now, if you are going to make a resource classification and geostatistical, you must have a grid data file. But if you don't have a grid data file here, we could also test generating synthetic grid, but this will be synthetic only for testing just the software. Okay, now this is generated synthetic grid for the boreholes that we have imported. Just if you have the real data, you have to import the real grid from here. Now we could see the display the 3D borehole or the boreholes in 3D. It will start drawing the boreholes. Just we have to wait until it finish projecting all the boreholes from the color, survey, and lithology files that we have imported. Now you see the ligand we have here in our data, schist B and schist A, and we have four veins, vein A, B, C, and D, and we have a cover or erosion cover. Just we increase this window. Okay, you see now this is borehole data that have been imported. You could also make some notation of the visualization of this borehole. Now, go to after importing your borehole, you could import also digital elevation model. We have a digital elevation model here. Just open. This is after importing the digital elevation model here. Now going to just you could start the 3D geological modeling. Take care for geological modeling. We have three modeling engines. One engine for explicit modeling, a second engine for implicit modeling, and third engine for hydrogeological modeling. Just you go to create 3D project and initialize the project. You have to make a name for your model. For example, explicit model, and make a select your resolution. For example, 35, and select the lithology columns here. Just I will select lithology itself, and just click on initialize project. Now start modeling. Go to we'll start from old geological event to younger geological event. So according to this data from the analysis of the borehole data, the older is schist B. Just build the deposit surface and start it by schist B and click OK. And just for explicit, select explicit here and click OK. Now, this is the schist P surface. Now, going to the second event, we build the schist A, click OK, And just we are using X-Place modeling here. Just click OK. This is a blue representing chest A. Now going to the younger events vein. The first event will be vein A. Click OK and explicit and click OK. It will create vein A. To show vein A, just click on opacity and decrease the opacity for schist B, for example, and also the opacity for schist A. Now you could see the vein A. This is vein A that have been created based on explicit modeling. This is the first vein A. Now we could build also vein B. This is vein B. Just explicit and click OK. This will create the green vein B. Just vein C and explicit modeling. It will create the third vein C. Now going to vein, the last vein here is vein D, and click OK, and select explicit and click OK. This will create the fourth vein here. And the last event is cover, which is erosion surface. Just build erosion as a cover and select explicit. It will create this red cover here. You could change also the opacity for cover, going to opacity and decrease the opacity for cover to show the underlying veins here. So this is explicit model, the explicit model that we have created. You could also create implicit model. Just go to implicit here and just select your deposit, select chess P, and just select implicit. Okay, so this is the implicit modeling for schist P. Now going to deposit, build schist A, implicit. Now this will build the schist A. Now going to veins and build the first vein E. Okay, and select implicit. It will create the first vein. You could see the implicit modeling for vein by changing the opacity of schist, the implicit schist, the implicit deposit schist P, and the implicit deposit schist A. Just you see the vein surface that have been which is in color in orange color. Now you could also make the second vein B. Okay, implicit. It will create this green vein, which is the second vein intersecting vein A. Now going to the third vein C, click OK, implicit. Yeah, it will create a third vein and going to build vein surface, vein D, and click OK and select implicit. Okay, it will build the fourth vein here. Now going to the cover, the erosion, build erosion surface and cover and select M.Elsayed. It will be built as here. Just change the opacity of cover, the M.Elsayed cover, M.Elsayed erosion. Just decrease the opacity like this. Okay. Now we could remove the points. Go to here at the bottom and click on points to deactivate the points of the drill holes. These points are the points of drill holes, and just show the explicit modeling. The explicit modeling here is without the points appear. Okay. And also the in-place modeling without the points here. You could also show the for Express, you could also show the wireframe. This is the wireframe or triangulation wireframe, or you could hide it. Okay, and this is the 3D isometric, the 2D map view, and the cross section here. Now going to after modeling here, you could create output volume, generate the volume for Express, for example. Now we have different tweaking functions. You have the ordinary tweaking, simple tweaking, universal, indicator tweaking, co-tweaking, and the disjunctive tweaking. Just for example, if you select to make ordinary tweaking, just run interpolation. Remember that we have done synthetic grid, so you could here do geostatistical analysis and resource classification, since you have make a synthetic grid here. But we prepare to import your real grid data because this based on the synthetic, this will be not accurate here. Now applying different kriging methods, for example, running the ordinary kriging. This is after running the ordinary kriging. You could go to create the block model. Just click on create block model. It will generate the grid tonnage report according to JORC here. Just if you would like to enter the cutoff here, for example, 0.5, and just apply visual, it will change it according to the new cutoff. Now you could go to resource classification and the process block model. You have different resource classification standards, the JORC, the NI, the SAM-RIC, and BERC, and the UNFC, and so on. Just let us select Australian JORC and confirm selection. It will apply the resource classification based on JORC. This is the resource classification based on JORC. Just remember that we have entered our synthetic grid. This is a synthetic, not a real grid that we have used. So it is better to use or to import your real grid from here. Just this is grid just to import to you real grid from here. But this is according to the synthetic grid that we have used. Also, you could do some geostatistical analysis, for example, to create biography. And this is the Gaussian simulation. This is the indicator simulation. Okay, and the E-type map. Okay. And you could also apply the analysis for probability map. And this is the analysis for probability map here. But please don't forget to, during modeling, you have to apply pinch out to veins just to avoid any extension of veins beyond the actual drill holes or actual drill holes that show the presence of these vein points. Just you have to apply the pinch out to vein before running this kriging and resource classification and block modeling and resource classification and geostatistical analysis. Also, you could apply the same for implicit. This is the implicit model. Just let me edit vein, pinch out to make pinch out for veins. Apply pinch out to veins, yes. This will apply the pinch out to veins. Then you could apply also the ordinary kriging. And this is after applying the ordinary kriging. You could apply the create the block model. This is create the block model as you see here. Okay, you could enter the cutoff. For example, 0.45 and apply. We'll change it according to the cutoff. And then you could apply resource classification and select the standard, for example, JORC. Now, this is the resource classification based on JORC. As you see, it is based on Australian JORC classification. Also, you could apply variography. Okay, this is after applying the variography and the Gaussian simulation. Okay, this is the indicator simulation. Okay, and the E-type map. Okay, and the last one, probability map. This is after applying different geostatistical analysis. Now going to hydrogeology, just switch into hydrogeology, and you have to input your data, hydrogeological data. If you don't, also you could generate a synthetic data here and just this is, for example, synthetic, and you have to import also the head pressure data or generate your own head pressure. And this will build up the 3D groundwater flow. And this is the contamination to visualize the contamination flow here. So this is about the third modeling engine for hydrogeology. In this also you have options. For example, if you go to explicit modeling, you have options to integrate with geophysical data. For example, with magnetic or gravity, radiometric resistivity, and also conductivity and seismic, just to load your real data. For example, for seismic, you have to load SIG-Y, real data, or to load seismic map or a 3D seismic cube. For conductivity, we use grid or map or cross section. For resistivity, grid or map or cross section. Since we don't have here real data corresponding to the same project, we could also make a synthetic. For example, to make a synthetic for magnetic, from here, generate a synthetic cross section. This will generate a synthetic cross section for magnetic, intersecting our model here. Also, you could generate a synthetic seismic, for example. This is a created synthetic seismic that is intersecting our and it is better to use your real data for geophysical survey here according to the boundaries of your project area. So this is a fast review about three engines that we have for Enigma Q. We have the image processing, remote sensing image processing and analysis engine, the geophysical engine, which is integrated with both of the image processing and analysis engine, and also is integrated with the 3D geological modeling engine. And the third engine is 3D modeling and resource estimation engine based on different standards for resource classification and also applying geostatistical analysis and block modeling. This is a fast review about the new updates of Enigma Q. Thank you so much, and wishing to you good night. Thank you.